All right, and now for our opening keynote speaker. Xavier Noria comes to us from Barcelona. He's been on the Rails core team since 2011. He's a part-time lecturer, lifelong learner, and Ruby Hero Award winner. He's done tons of Rails core work on Zeitwerk, among other things. Please help me give a warm welcome to Xavier.
First of all, let me thank RailsConf for inviting me to give this keynote, which is truly an honor for me. All right, autoloading. So for those of you new to Rails, autoloading is that feature in the framework that allows you to just program having all your application classes and modules just available everywhere without using require. This is also related to reloading and eager loading, okay? But that's autoloading in the Rails framework. Autoloading has been in Rails since the beginning. And in Rails 6.0, we shipped a new implementation, an alternative implementation of autoloading, which was coexisting with the previous autoloader for 6.0 for 6.1. And that was like a transition period that took us to Rails 7, where we finally dropped the previous implementation because the new one is better. This is the commit where this happens. This is my commit dropping the support for the previous autoloader, which we called the classic autoloader, all right? This commit is very symbolic. It's very symbolic because there's years behind that commit. And this was like an entire journey reaching this point that I would like to share with you today. All right, so constants, even more back in the day, is a not very well documented feature of Ruby. And back in the day, Rails didn't have even documented autoloading. So years ago, I was interested in these topics and did research by myself, trying to reverse engineer how things work. And as a result of that research, at least I could share some of the things that I had learned with talks, for instance, and with the autoloading guide. This autoloading guide had one infamous section, which is the section about gotchas in the classic autoloader. Here's a scrolling screenshot of that section. That is so long that I had to put it diagonally, you know, in the slide. Why did this happen? Well, the technique the classic autoloader uses or is based on has fundamental limitations. So this section was like documentation. I'm sorry, this is the way it works. It is not technically a bug because the gotchas were a consequence of the limitations of the technique itself. So I would like to leverage this presentation to explain to you why did we have this section with gotchas in the previous autoloading guide. So let's do a very quick recap about the most important things we have to know about constants in Ruby. The first thing that we have to know is that constants belong literally to class and module objects. This is something quite particular in the Ruby programming language, because in most languages, a constant, more or less, is just like, you could say it's like a variable whose value is protected against changes, something like that, you know? It's like a very simple topic. But in Ruby, it's a very deep topic. And this is one of the particularities of the Ruby programming language. Constants is something that belong explicitly to class and module objects. So you have to imagine that every single class and module object has like an internal hash table that maps constant names to values. That belongs to the Ruby model, all right? And you have API to manipulate that hash table, quote, quote, which is the constants API. You can ask a module or class object about the constants it is storing. You can dynamically set and remove constants. There's an API around this concept, okay? Top-level constants belong to object. So if you say foo equals 1 at the top level in a Ruby script, that foo constant, capital letters, is stored in object. Object receives a new entry in that hash table. It's not just like a pure identifier like a variable, okay? It has more consequences. It is stored in the internal hash table, quote, quote, in object. All right. So we have constants stored everywhere. And when you refer to a constant in source code, Ruby has to do a lookup to find that constant. We are going to see two algorithms that perform lookup in different ways. The first one is the algorithm that is being used when the constant reference is relative, okay? A relative constant reference is like the regular one, the one that does not have colon, colon to the left. So for instance, in this source code, we have admin users controller and an action new, and that action has user.new. So that user, the user constant, because Ruby does not have syntax for types. So when you see this user here, this is not a type like in other programming languages. This is a regular constant. This is an expression that evaluates to a class object, all right? So this is a relative constant. How does Ruby resolve this constant? There's a lookup going on. Let me first introduce, to explain this, the concept of nesting, okay? So at any given point in the source code of a Ruby program, there's something that the interpreter is keeping internally for you, call it nesting, which is a collection that reflects the nested classes and modules that you have at that specific point in your source code. So we have here two examples with two different nestings, okay? In the first one, we have module A, class B, and then in the spot where we have the comment, the nesting is reflecting this nested module and class. So it's A colon colon B, A, okay? Now, in the second example, we have class A colon colon B directly. So the nesting is different. Why? Because you see there's no module A and then nested a class keyword. You only have one keyword, class. So the nesting only gets one class object pushed, all right? So A is not in the nesting in the second example. Okay, enough to understand roughly. I am not going to be very detailed, but enough for this talk, how this user constant is looked up. So you could think, why? User is like the top level, okay? It's like the global user, right? This should be immediate. It is not. There's a lookup, and from this spot in the source code to the point where Ruby finds the user constant, there's a number of steps. So it goes like this. We saw what's the nesting. So the first thing that Ruby checks is the nesting, because for Ruby, this is the way to emulate the concept of a namespace. So we have to think that we are within a namespace there that has to be checked first. Then if within that namespace we do not find things, then we continue looking up the constant. So it works like this. The user constant. Does the user constant belong to the admin colon colon users controller class? Let's suppose the answer is no. Let's suppose we are looking for the top level one, okay? But first, that one is checked. This is the namespacing emulation of Ruby. Now, it is not found there, okay? Then we still check the nesting upwards. Admin, do you have a user constant? No. All right, let's continue the search. The search now continues. We have exhausted the nesting. Then the search continues in the ancestor chain upwards. So the superclass of admin : users controller is application controller. Application controller, do you have user? No. Goes upwards, upwards. Eventually, object is in the ancestor chain of all classes. So eventually, object is going to be checked. And remember, top-level classes are stored in object. So eventually, you hit object, and then Ruby is going to find the user constant, and then you get the value, and the program resumes. So you see, there's a number of steps. If we made a typo or something, and the constant really was not defined, in the end, there's a fallback, which is a callback called cons missing. So if the lookup failed, cons missing is going to be called, and all classes and modules respond to cons missing. The default implementation raises name error, but you can overwrite that implementation. And the classic autoloader did that, as we are going to see. Now, absolute constant lookup. This is easier, all right? So in the previous one, we did first the nesting outwards, and then the ancestor chain upwards, and there's a fallback to cons missing, okay? Well, there's one particular exception with modules, because modules do not have object in the ancestors. So if the inner namespace is a module, then Ruby manually checks object to still find user, okay? Well, so this is the main idea. First, the nesting outwards, then the ancestor chain upwards, and fallback to cons missing. Now, here we have product. First is a constant. And product is, this one is resolved with the previous algorithm, because that one is relative. It doesn't have : to the left. So first Ruby finds product, okay? Let's imagine that everything is correct, and product gives you a class of module object. Then update inventory job is the one that is going to be resolved with the new algorithm that we are going to explain. That one is like qualified, absolute, okay? It's a scope to product. So what happens here, basically, you check in product. If it's not in product, you check the ancestors, okay? And if the ancestors had object, nowadays object is skipped, because otherwise you could have product, string, for instance, and it could be found. That's strange, because a string is top level, not the scope. So you check in product, and you check the ancestor chain of product, and skip object if present. Easier. All right. So now we have the knowledge to understand why the classic autoloader couldn't work. Because what was the idea behind the classic autoloader? So we have the file name conventions that you know, all right? So you know that in Rails, the file names match constant paths, with namespaces being represented as directories, right? We have the file name conventions. Then we have the autoload paths. The autoload paths are APP controllers, APP models, APP helpers, okay? Those folders in the project that represent the top-level namespace object. And here's the thing. Rails defines a cons missing hook in the classic autoloader. And that cons missing hook, there's a few hundred lines of code there, but the raw idea, the basic idea is the following. If you get the user constant that is missing, then you get the name in const missing. Hey, this constant is missing. Then the autoloader underscore that constant name to get user lowercase, and basically walked the autoload paths looking for user.rb. That's the idea. You get called, you underscore, you look for the file. If you find the file, you load the file, everything works. Okay, so makes sense. However, the problem is that const missing does not get the nesting. Const missing does not know if the missing reference was relative or was qualified. So const missing and the classic autoloader basically cannot emulate the way Ruby resolve constants, does not have the necessary information. That's like a fundamental intrinsic limitation of this technique. However, even if you had that information, there's still one gotcha, which is that module const missing, as we have seen in the algorithms, is the last step. So if you want to autoload something, and in this lookup, you find a constant with the same name elsewhere, Ruby is going to be able to resolve it. Not in the place that you were expecting, but Ruby could resolve that constant in another namespace. What happens then? That const missing is not even called, because it's the last step. If you do not hit the fallback, bad luck, I could resolve the constant. So Classic just couldn't, so Classic was extremely helpful. It allowed us to work without requires for 15 years. But unfortunately, it couldn't match the way Ruby works with constants. Now, there's another thing in Ruby, call it Autoload, all right? Autoload is a method that allows you to say in class and modules, okay, if you are looking for the user constant in this example, please load the file that goes in the second argument, okay? And the key point here is that when the constant lookup is happening and Ruby is checking class and module objects, do you have this constant? Do you have this constant? The logic is a little bit deeper, because what happens in reality is that if the class or module does not have the constant, but has an autoload defined for that constant, then it executes the autoload. So this is a key observation that I realized like years ago, and that tells us that if we could base autoloading on this feature, it could just work. Because that's built in the interpreter, it's built in the lookup paths, and it's going to respect everything about the semantics of Ruby and constants, because it is Ruby doing the job at the right place at the right time. So there was like a rough idea of one possibly alternative way to implement autoloading, which is the following. You still have file name conventions, you still have the autoload paths, but then instead of reacting to const missing, you go beforehand, you scan the project tree. You first scan before the application is being executed, let's say. First scan. And if you find user.rb in the file system, you camelize that and you define an autoload for user that is going to load that particular file. That was the idea. I have had this idea for a long time. Making this happen was for me like a Grail project. However, there were some technical difficulties implementing this. Let me show you them. There are a number of them, and then there's a mystery one at the bottom that is going to be a secret for a little bit. So let's go one by one, okay? The first one is that module Autoload uses an internal require. So in this alternative implementation, you want to be aware of when things are being autoloaded, because you want to keep track of what is being autoloaded. Maybe you want to lock a trace. Maybe you want to trigger callbacks. You know, you need some housekeeping. In order to do that, Autoload loads things with require. The technique is to decorate thin wrapper around require. But Autoload was not using the kernel require that we know, was using an internal C function that was not reachable from Ruby. So we cannot decorate require, so we have a blocker there. Who unblocked this fine gentleman? This fine gentleman, Aaron Patterson. So Aaron patched in this commit Autoload so that it went through kernel require. The motivation for this particular commit was that Ruby gems also decorates kernel require. So regular requires go through Ruby gems and it has control over them, but requires triggered by Autoload were bypassing that decoration. So with this commit, this got unified. This was in 2015, as you can see, and shipped with Ruby 2.3 in Christmas 2015. So, hey, this is solved now. Let's go for another one. Require is idempotent, as you know. If you require something and then execute the same require, this is an artificial example, but you know the common use case is that you have requires for the files in different places in your project, so only one of them is going to be executed, and the rest does not need to be executed, and require is idempotent. This is a problem for reloading, because since Autoload uses a require, if you reload, as we do in Rails, and we want to reset the state of the project, what happens? OK, we have to scan again, set Autoloads, and when the Autoload is going to be triggered, I'm sorry, but the require is not going to fly. Why? Because it was already executed in the previous, before the reload. All right? So this prevented the idea of reloading. Now, before doing Ruby, I did Perl for some years. And in Perl, you do quite dirty things. And there was an analogous situation for which I knew a hack. How does require know that the file was already loaded? It keeps internally a collection of files that have been required, call it loaded features. So loaded features is mutable, and if you if you remove the file, you get the required working again. All right, so we have one way to make reloading work. Yes, OK, we have two. Now, there's no API to remove an autoload. So we have seen the autoload call that allows you to set an autoload. But if you reload, you had set an autoload for something, and then the user delete that file, to be clean, the project should have no knowledge of that file. You cannot carry that autoload forward because it doesn't make sense for the current state of the project after a reload. So to be clean, ideally you should just remove that autoload. But there's no API for that. So Matthew Draper is a member of the Rails core team, and we shared with Matthew this view for this alternative implementation, and we had some conversations with Matthew along the time that were very encouraging and inspiring, like, yeah, I don't know, checking options, thinking about the problem, right? And I learned from Matthew the way to overcome this one, which is that it happens that if you remove const as if the constant was already loaded, the autoload is gone, okay? So this makes sense because then I learned it with time that the way Ruby understands autoloads in the API does not quite distinguish constants that have been like really loaded from those that have an autoload set. So this is consistent with that view of the API, and it works. You just remove const, the autoload is gone. Right, closer. No, what about implicit namespaces? An implicit namespace is a namespace that does not have a Ruby file defining, okay? So you may recall that if you have, for instance, an admin namespace, if you do not need to define something in the admin module or class, you do not need to write an admin file. So Rails sees that there's directories, call it admin, that's enough. Rails is going to define a module for you, call it admin, okay? In the previous implementation, well, you get called, admin, okay, I define it on the fly, resume. But here, you are not called. You have to be proactive, okay? So I didn't know how to do this, but there was like a couple of ideas. One idea is, well, if I hit a directory, at that point, at the scan time, define the module and continue recurse, okay? This has the cons that is not as lazy as the previous autoloader. It's not as lazy. It could be a good enough compromise, I believe. But, well, there's another tentative idea, which is to set an autoload on the directory. That would mean that there's going to be a require on a directory. This is a little bit strange because require is supposed to look for files. But, well, it was a tentative idea. So this was not like, I don't know which is the solution to this, but I believe this can be solved somehow, you know? And then we had this last blocker, explicit namespaces. Let me tell you what's an explicit namespace. You have the namespace defined in a file. So in hotel.rb, you have hotel.rb and hotel pricing, okay? In order to evaluate hotel.rb, we have to have hotel : pricing defined because it's there at the top level with an include. At the same time, we cannot evaluate hotel/pricing.rb because that needs hotel to be defined. So it's like a chicken and egg problem. We cannot go for any of the two. What to do with this? So I had no idea what to do with this, but I started working on that. All right, this is, for curiosity, the message that I put in our chat in the core team, announcing that I don't have all the answers, but I am going to sit down and try to solve this problem. Now, the next person to come here is my friend Rafael Franza from the Rails core team that says, hey, we solved this in a hackathon in Shopify. What? So this conversation is so important that I'm going to share with you, all right? So I said, the next day I announced this. I say, got a prototype of the autoloading idea working without namespaces, because namespaces is what complicates things. Includes reload, and it is about 40 lines of code. Namespaces are where the fun is, but the bootstrapping feels good. So we got the ball rolling, okay? And then Rafael says, hold that thought. I'll open source something. There you go, with a repo. And I say, that's awesome. I am in bed now, can check the code. How do you define autoloads for non-anonymous namespaces? So I am in bed now, can check the code. Who are you fooling to? I, of course, wake up and went to, to find out immediately. So the solution was tracepoint. And Dylan Thacker Smith was the author of this proof of concept, let's say, in Shopify. and I have never met him, but I owe this guy an infinite stream of beer or scotch or water or whatever he fancies, because this was the inflection point for this project. So this is the idea. Trace point allows you to define callbacks for certain events that happens when the program is executed. There's one callback which is call me when a class or module is defined. So if you set a callback for this event, then you can do the following. When the class when the class keyword is executed and the hotel class is defined, before you reach the next line, you are called. So the hotel class is defined, but include pricing is still not executed. So you are on time to go to the directories that conform the hotel name space, set autoloads for hotel, and continue. Yes. However, is this performant? Because tracepoint, has a reputation of, okay, when I running trace points, it has overhead. So does this has an overhead? I reached to Richard Schneeman from Heroku, Code Triage. He checked some projects of him having the trace point defined to see whether by itself created overhead. He didn't find any measurable difference. I also reached out to Sam Saffron. So he checked things out. There was some feedback that I addressed, but the conclusion was, this seems to be fine. In the benchmarks, we don't find anything that is measurable. So we have it. We have it, except for the secret, but we have it. So at this point, I knew we had it. Now you have to sit down and write it, because from the raw idea to an actual implementation that can run in production, there's a myriad of micro decisions, edge cases, and things that you have to work on. But we have it. Now you have to sit down and do it. So I sit down. This was a very intense period for me. I am a consultant. I even billed less to work with this because I was really into it. And I started working in active support because the previous autoloader was defined in active support. Okay. The previous autoloader is implemented in one module. Basically, the main parts of the logic, call it active support : dependencies. This module has module functions that are like, excuse me, that are managing global state. Global state, I mean, so which constants have been autoloaded, which are the autoload paths. All those are things that are one per process, and that's the way it works. So I started doing something similar, only with the new logic, right? So when working on that, I thought, why I am defining module functions that manage global state? This could be a class that you can instantiate and has its own, the object has its own state. Well, yes, I started doing that refactor just for the sake of, programming. But when I was working on that, I made a connection with another pain point of mine. That pain point was that in any regular Ruby project that is not like small, in my experience, getting the requires right is difficult. It's difficult because require has global side effects, and then you forget them, and then depending on the code paths, you realize that at some point you forget to require something, but maybe that's a Heisenberg thing because depending on how you reach that point, maybe it was loaded before, it's brittle. Also, how do you organize the require so that you can load one particular file inside a namespace and have it self-contained? That's difficult. So I had a realization. If we have different instances managing different source trees, we could have loaders coexisting in the same process managing different projects. So then I changed the scope of the project. So from working on Rails, we switched to wanted to have an independent gem designed for any Ruby project, supporting coexisting autoloaders in the same process. And then the idea is we are going to do a gem like this, more generic, outside of Rails. And then in Rails, we are going to have glue code. So the implementation is out there, and Rails just does, the integration between the configuration of Rails itself and that thing. So that was it. What about the Rails integration? Now we have a gem, we have to integrate with Rails. Now, the goal is we are going to ship with 2 autoloaders, and you can opt out of the new one. That's the plan. You can still use Classic. Why? Let me tell you, because for 15 years, the previous autoloader was brittle. Not his fault, not its fault. It was just the way it was because of the reasons we have seen. So people had scars about this. And if you want, psychologically, if you want, I didn't want to have the experience of doing something drastic, like we are going to ship a new autoloader, people. You are going to need to do a migration from Rails 5 to Rails 6, because that could be a little bit scary, okay? So I wanted people to feel safe in a way. So we are going to ship this. This is new, okay? But you have the ability to migrate Rails 5 applications and still use the previous autoloader that maybe is not perfect, but that you know. And you have maybe in this tweak in this project and this tweak in the project thought for that particular autoloader, peace of mind. Maybe you later, after the grade, you can do like a task force or something like that that is more scope. But you had a way out. And this was, for me, very important for users of Rails. Now, if you are starting a brand new application, yes, the default is the new one. The new one is better. But if you are upgrading, peace of mind, you can still work with a classic autoloader, and you could do that for 2 releases. Now, the tricky part is the classic autoloader, so we have to ship 2. And for this reason of peace of mind, I want to absolutely make sure the classic autoloader works as it did in Rails 5. Absolutely. No difference. So if you start, making both coexist with if and then, and, and tweaking the logic, how can you make sure that that's going to be the case? Well, generally you can. My idea here was I am not going to touch 1 single comma of the previous autoloader. That was the way I could guarantee that the previous autoloader was going to work in your upgrade as it did before, despite making these changes. And let me show you the technique. So when Rails boot, this is code from Rails 6. In Rails 7, this code does not exist anymore, okay? So when Rails boot in Rails 6, by the end of the boot process, there's code that says, okay, if you selected Zeitwerk mode, which is the name of this new mod, yes, then we are going to require an integration code, and that integration code is going to take over the other autoloader. So it's like we are going to hijack. So we have not touched 1 single comma of active support dependencies.rb. Takeover. Takeover defines the autoloaders and then decorates dependencies. Let me give you an example. For instance, the clear method is the one that is called when you reload. Okay, this is the implementation in the previous autoloader. So the integration defines also a clear method that does reloading using the new thing. And then you go and prepend this module on the other module. So we are hijacking. So this is not calling super, like you would do in a typical decoration. It's not calling super. This is hijacking. This is, I am taking over the calls. Because this is public API. This is another difficulty. This is all public API. So this public API has to still exist and has to behave, ideally, as it behaves in the other one. So this is the technique. You hijack. Now, in the module, there's like, I don't know, 30 private methods that were the implementation of the previous autoloader. And they are still there in this way, okay? Because you only hijack the public interface, the one that you need. But those private methods that were needed by the previous implementation, well, is that a problem? No, nobody is going to call them. They are private, and so the entry point to those methods is const missing that is no longer running. So that is going to be dead code. Fine, we didn't touch anything. All right, this is ready, but we have the gem, first version, we have the integration, but this is in a branch. We do not merge. Why? Because of the secret. So, the last blocker was that module autoload was deprecated. Yes. Which level of deprecation? Let me show you. This is much, okay? I strongly discourage the use of Autoload. In any standard libraries, Autoload will be dead. And then in the middle of the description says, so I hereby declare the future deprecation of Autoload. Like, this is level 11. All right. So at this point, you may ask, so you have done all this, you have gone through all this, knowing that probably it is going to be for nothing, because this is very, very explicitly, it has been deprecated for 7 years, I believe it was. So it was like, you know, have you gone through all this and done this work knowing that probably is not going to see the light of the day? Yes, I did. Why? For the fun of it? For something that I believe we all in this room share, which is the joy of problem solving. This was my Grail, so just solving the problem was an enormous personal satisfaction for me. And this is out of my control. So let's see. All right? Now, there was some discussion in this thread because we said, we have these plans. What do you think about that? And I want to share with you this paragraph that I wrote, because this belongs to, in my view, open source etiquette, okay? So when I entered this discussion, I said, first and foremost, I like to be very straightforward, saying that if kernel autoload is killed tomorrow, that would be fine with me. Despite everything, that would be fine. And I am being absolutely sincere here. I shut down Zeitwerk and Rails 6 plans without regrets. I took the risk. It's my responsibility. So if you move forward with this deprecation, I have nothing to say. Go ahead. It's fine. The Ruby core team are the stalwarts of the language. You know better than anybody else the rationale for your decisions. And if you believe you have to definitely say goodbye to kernel autoload, I profoundly respect it. And that's part of open source etiquette, that when you want to interact with someone that is running a project, you have to take into account that maybe you don't have the whole context, that maybe they have like a perspective of how things fit together or how things are going on, you know. They may have different preferences, they may have different trade-offs than you have. if you accept something, you are going to maintain it forever. So to me, being respectful for other team members and accepting their decisions about ideas that you may have, for me, that is fundamental. Now, having said that, yes. Now, having said that, we can have a technical discussion. These were the problems with the classic autoloader. We all know that for 15 years, this has been brittle. And this particular implementation solved them. And also, discussing with a working implementation, it's much, much, much easier. Discussing with code that you can see, it's much, much easier than discussing, ideas, potential solutions. So now Mats enters the conversation and says, OK, I withdraw the proposal. So when I saw this reply from Mats, I was speechless. For me, this speaks volumes from Mats. Despite all the context about that deprecation, he still listens, and he still is understanding and generous enough to go and say, all right, let's withdraw this. It speaks volumes for me. So we have it all. We have it. We made it. This ships with Rails Beta 2. The first thing, February 25, 2019. Now, let's take a break. Let's talk about a curiosity of the project that I want to share with you. The name, Zeitwerk. So, originally, the gem was called Autoloader. Simple. Autoloader. So, I have the gem written, called it Autoloader. The integration in Rails written with Autoloader. The blog post written with Autoloader. And then I'm ready, I push the gem, and Ruby Gems tells me that the name is taken. I hadn't checked it. Yes, so there was a gem written a while back, called it Autoloader. I couldn't reach the author. What to do? I had to find a name quickly. So I looked for inspiration in things to see, OK, what is going to be the name? I checked some options and looked for inspiration in things that I like, OK? So one thing that I like very much is watchmaking, mechanical watches, OK? Watchmaking has a very unique, for me, intersection of engineering, of craftsmanship, of artistry, of exquisite attention to detail that attracts me a lot. And watch aficionados often have something that we call the Grail Watch. The Grail Watch is that particular, so there's a ton of watches out there, okay? But for many people, there's one that's the one that speaks to you. That's the one that if things go well, someday perhaps maybe you are going to have. I had a Grail Watch. Let me show you this watch. So beautiful. The Zeitwerk from Alanga and Zona. This was my Grail Watch. And I was kind of working on my Grail project. So I connected both ideas, and I said, OK, I'm going to connect my two Grails with a name. And that was Zeitwerk. Now, Zeitwerk is a German word. I do not speak German. So Martin Schurig, which is a colleague in a previous client of mine, kindly recorded with beautiful voice the correct pronunciation of Zeitwerk in German, which I would like to share with you.
Zeitwerk.
Yeah, there you go. Second.
Zeitwerk.
Ah, beautiful. All right. Martin, this audio is in the repository. Yeah, and for to make this section complete, I have to share that eventually, time later, I got the watch because you have to fulfill your dreams. OK, we are in beta 2. We need to go from this first implementation to Rails 6 final. How did I test the integration? Well, I am also the author of Rails Contributors. Rails Contributors is a super small application. It has 3 autoload paths, 12 classes and modules. So enough diversity of things to get the basics right, OK? But it's a tiny application. Now, something amazing happened, which is that from here, I go to which other application? To Shopify. So from this toy, now Shopify wants to integrate Zeitwerk in their monolith, in their application. And this is the best that could happen because we are in beta. We are on time to polish things. We are on time to make backwards compatible changes. And because Shopify is a huge application, it has 90 engines, more than 600 autoload paths, 25K classes and modules. So if something of performance or anything has to be polished, it's going to show up here. This is what you want at this stage. This was amazing for the project. Now, Shopify is huge. We have a tentative first non-validated implementation of something which is a little bit tricky. Who is going to do this? Because, man, this is like migrating this application with something that is tricky, not validated. You need someone that is really good. And yes, that was Jean Voussier from Shopify. Yes. Yes. Please, go ahead. He totally deserves it. Jean Voussier. So we did an amazing collaboration with Jean for, I don't know, for a couple of months intensively, and then forever, because Jean has been always in contact with Zeitwerk, proposing things. So we discovered APIs that were wrong. We discovered performance issues or things that were right, but you first write it right and then make the performance. And so anything that could be improved was amplified by running on Shopify. This was amazing. The gem was way better, and the Rails integration was way better thanks to this collaboration with Jean. Let me show you this tweet. Jean pops up everywhere with amazing work. I know you are not on Twitter, but thank you by root, which is his handler. And then Ufuk says, Jean is most definitely the unsung hero of the Ruby community. I love working with that guy, and I personally totally subscribe these works. Yes. And I am also very happy to share with you that Jean just joined Rails Core last week. Yes. Also, an update on that tweet. He's on Twitter now. All right, Shopify completes this migration in May 3, 2019. 3 months before Rails 6 final. So that gave me a boost of confidence in shipping this integration with Rails 6 final, because Shopify was running in production with this and in development as well, of course, for 3 months. So yeah, I'm sure some details are going to show up in other projects, whatever, but man, this is running Shopify. So that's a great test for what we are going to ship. And Rails 6 ships with this alternative implementation in August of 2019, finally. Now, this is out, okay? And people start to do migrations. I want to share just a couple of them. The first one that has a special place in my heart is the migration of NanoC. NanoC is a static website generator. So this is a gem, not a Rails application. This is a gem. So nowadays, there's like 260 gems, more or less, loading with Zeitwerk, which was the vision. You have not only Rails applications, but every gem, and indeed other web frameworks can use the autoloader. So this is the entry point for NanoC. And NanoC, instead of doing cherry picking requires individual files, it maintained this list in the entry point. So it's kind of eager loading, right? So at least you do not have to be doing requires manually everywhere inside the project. You put it all in the entry point, done. All right. The patch of NanoC, NanoC had this patch the day after the first beta was out of Zeitwerk. And the patch looked like this, everything delete. Yes. To me, it was amazing to see this patch because yes, that's the vision. That's what we were after, okay? You have to think that this list of requires has to be maintained. So every time you add a file or remove a file, you have to remember to go here and edit this list. And this list has to be ordered, because if files, if when you execute a file, you are referring to a constant at the top level because you are including a mixing or whatever, that has to be loaded before here. So it has to be maintained and in order. So the patch just deletes this. This is the first gem, to the best of my knowledge, that used Zeitwerk. It used Zeitwerk way before Rails. And the patch was merged with the first stable release of Zeitwerk. The other one that I want to share, there's many, but I have some memories of this one. This course migrated in October of 2019. That's the pull request right there. So this patch, migrating this course, has 500 required dependency delete. And that was, for me, like a trophy, because required dependency we have not seen it, but most of that infinite list of gochas was like, this is the gocha, this is why it happens, and this is the solution or the workaround. And the workaround oftentimes was put a required dependency for something that you want to make sure is loaded at this point. So this was like a trophy. Why? Because you can imagine that behind every single one of those required dependency, there was a headache. There was a puzzling time of something that was not loading, sometimes like a Heisenberg bug that sometimes happens, sometimes not. It happens in CI. Why is not this constant not found here, but in other runs it is found? You have to do research, and at some point you realize, oh, we are facing this particular gocha in the list. We need this required dependency. I am sure each single one of those required dependency was a pain in the ass. So getting rid of this is, yes, that was it. So if you are migrating to Zeitwerk, there's a guide that is going to help you with everything you want to know about doing this. And finally, after all this journey, something really beautiful happened this year, which is that I got a Fukuoka Ruby Award for this project. This was an incredible recognition for this work, and it made me be proud and happy, but there's something that still makes me happier, which is that issues related to autoloading have virtually vanished. So before this, it was a constant stream of issues and tickets, not because of the tickets themselves, but because that means people are having problems with the framework, with infrastructure, instead of focusing on the work, on the applications. That was not a good user experience at all. So issues have virtually vanished. They are gone. It just works. So I monitor the Rails repository. I monitor Twitter. If you want to read me on Twitter, you mention Zeitwerk, I'm going to see it. Stack Overflow, it just works. So Zeitwerk got the spotlight in this particular presentation. But the goal of the project is to vanish. The goal of the project is that it works so smoothly, so transparently, that you indeed forget that he's even doing just discreetly his work. And that's it all. OK, thank you.